Okay, so welcome, chapter 1. Here we go. Chapter 1 is really gonna just give you a lot of terminology, and so that can be a little bit tricky, but it's terminology that we'll need throughout the course, of course. That doesn't make sense. Anyways, and then a couple of calculations in the second part that we're going to work through. But I want to start with talking about what is statistics. Why are we even here even? And so a lot of you have to take this course as a prereq for graduation. And the reason for that is whenever we have some hypothesis or some theory, we're going to need to use statistics. And that's so statistics in general is when we use data from a sample. So we go out and we collect a sample of information, and then we use information from that sample, which we call data, to learn something about the population. Ultimately, what we want to know is we want to know something about the population. So I will add here that if we want to prove or disprove a hypothesis, or if you prefer calling a hypothesis a theory, that's fine, or theory, we will need to use statistics. And so that's why, oops, static, that doesn't make sense. Statistics. So that's why we have to take this course. People usually think that I just have all these sports stats up my sleeves or like probabilities. I do not. That is not what statistics is all about, which you'll find out soon enough. Okay. So what I want to point out here is that, okay, so we said we use data from a sample to learn something about the population. Now, if we think about this, let's say I am interested in the average. That's pretty common. I want to talk about the average measurement of something, right? Let's say we're talking about the average distance, for example. So then I would take a sample of distances and calculate the average, but then I'm trying to know something about the population average or the population average distance, right? And so we have these averages, right? I have the sample average and then I have the population average. And so we need some terminology to differentiate between those two, okay? And so we need to be able to distinguish between information from a population and information from a sample. Now, a population is everybody or everything of interest. And so it's going to be really useful to be able to determine what the population is from a question or something like that. So we'll practice that a little bit. And a sample is a carefully selected subset of the population. And we're going to talk more about sampling in a little bit. And how do we collect that sample so that it is representative of the population, because that's what we need in order to use the data from the sample to learn something about the population. It has to be representative of the population. So a calculation or a number derived from the population is called a parameter. Okay, and so in general, we're going to have, let me see here, a population parameter. Okay, notice P and P. And then a calculation or a number derived from the sample is called a statistic. Notice S and S, right? So a sample is called a statistic. Now, it gets a little bit confusing, and a lot of the time, unfortunately, it is um, context based, right? And so a calculation or number derived from the sample is called a statistic, right? Whereas here, when I said if we want to prove or disprove a hypothesis, we will need to use statistics, and that is the practice of statistics the entire course. But a statistic is just sample information. So the sample average, for example. Right? Okay, let me grab some more here. I'm gonna grab this whole chunk here. Copy. Oops. So we use a statistic, right, to learn about its corresponding parameter. Well, where did that come from? Well, it came from the definition of what is statistics. What are we studying here, right? So when we use data from a sample, that is a statistic, right? So when we use a statistic to learn something about the population or its corresponding parameter, right? So a couple of the common measurements that we're going to talk about are the mean. Okay, the mean is going to be really, really important, and the mean is the average. Okay, and I'm going to use those two terms interchangeably. In the beginning, I tend to try to say average a little bit more, just to emphasize that, okay, you already know what this is, right? But as we move through, I'm going to start talking about the mean, but they're the same, right? So establish that connection in your mind, okay? And so we'll also talk about the standard deviation or potentially the variance, okay? And so like I said, right, when we're talking about the mean, we could be talking about a sample mean or the population mean. So we could be talking about a statistic or the parameter. Now, we need different notation here, right? Because otherwise that would be a real mess. Oh no, and I'll talk a little bit more about these guys here. Mu, sigma squared. I'll write that down just in a second here, right? We need different notation for whether it came from the sample or from the population, because otherwise, I don't know, we couldn't do anything. We have to. Yeah, um, we just have to. Can't figure out a way around it. So some common notation, the mean is denoted by X bar. Okay, so what I'm gonna do is I'm gonna kind of zoom in here and maybe use a different color and say this is pronounced as X bar. Okay. The standard deviation for the sample is just denoted by S, a lowercase s. Okay. Whereas the variance is going to be S squared, which is really just the standard deviation squared. Okay, so they're definitely related. Okay, without knowing exactly what the standard deviation and the variance are, we can understand that they're clearly related just by the notation. So here, this is the standard deviation squared. Okay. Oi, it's so small. Okay. Over on the parameter side, right? So this is for the population. The mean is denoted by mu. And what you'll notice is that as soon as we're talking about a parameter, we're going to be using Greek letters. Okay? There's one exception, sort of, at the very end of the course, but by that point, we'll be so familiar with just using the Greek letters that it's going to be okay. So the mean, the population mean, is denoted by the Greek letter mu. So this is pronounced mu and written mu, right? So if you're ever typing, a lot of the time I'll just get you to write stuff if I want to see your written work, so you don't have to type. But often, if you're writing your notes and you don't like drawing this fancy M, essentially, then you can just write mu, and that means the same thing. Okay. The standard deviation, the population standard deviation, is denoted by a lowercase sigma. And then of course the variance, same as for the sample, right? We had S as the sample standard deviation and S squared as the sample variance. Now sigma, lowercase sigma, is the population standard deviation, and a lowercase sigma squared is the population variance. So here, this is sigma. Clean that up a little bit. Sigma, and it is lowercase, in case you were curious. And then, of course, this is sigma squared. Okay. So notice that we use different notation for the statistic and the parameter. And it's going to be really, really important to keep these straight, right, as we work through problems. Parameters are denoted by Greek letters, which I said, and anything with a bar over it is a sample mean or a sample average. So anything with a bar over it is just the average of whatever is underneath it. So X bar is most common. X bar is the average of X. Okay. I'm going to extend this bar over the height there. So the height, sometimes we'll use the name of whatever we're taking the average of, and then put a bar over it, and that just means it's the average height. Okay. How about this? It's your average smiley face. Oh, and I want to bring in a funny, but let me just go find it. I found it. Except it should be statistics. Anyways, so I thought that was pretty funny, because there is going to be a lot of kind of terminology and Greek letters and notation and the works. Okay. So let's see here. Let's start introducing some terminology here. What? That wasn't it? It was not. That was just the beginning, friends. Okay. So we probably have a pretty good idea that we will have collected some data, and we're going to analyze that data, and we're going to calculate things from that data. And so we need to be able to talk about data sets. And kind of the main thing that we need to be able to talk about is what is a variable and how can we classify these variables. So usually data is stored in a spreadsheet, and each column represents a variable. So I think that's the easiest way to remember, what is a variable. If you imagine a spreadsheet, an Excel spreadsheet or whatever, numbers, what have you. They all look the same, right? You're going to have your columns with all the information that you need, and your rows will probably have, you know, the subject or the person who gave you those results, or um, kind of whatever you've collected information from. So a variable is any characteristics, a number, or a quantity that can be measured or counted. So notice that we say characteristics, and then we talk about numbers. And so all of those get lumped together into a variable, and then we're going to split those up briefly here. So we want to talk about some variable terminology. Okay. So we're going to look at this on-time data for all flights that departed New York City, which is JFK, LaGuardia, and EWR. Now I have to look it up. Anyways, I don't know. I probably do, but it escapes me. In 2013. Okay. And so we've got this data set, and it's huge. Okay, and I think it's in here, or at least a summary of it. So let me just grab it here. So this data set has 336,776 observations. That is a lot, and 19 variables. Okay, so let's think about what would our spreadsheet look like. Well, if we have 19 variables and this many observations, right, imagining your spreadsheet, right, going down this way, you would have 336,776 observations, right? That's how many rows of information that you would have. Each flight, in this case, is an observation. And then across here, you would have 19 variables, right? And so now you have an idea of what this spreadsheet would look like, or this data set would look like. So we've got some information on the variables that were collected. Okay. And so we've got the year, the month, the day, which is just going to make up the date of the departure. There's the departure time, the arrival time, right? And it specifies the time format and stuff like that. That's not important for us, but might be fun to look at later. There's the scheduled departure time and the scheduled arrival time. What can we do here? So there's the actual departure time and the scheduled departure time. So of course, from this information, we can derive more information, right? We can derive how delayed it was, or maybe how early it was, right? Same thing with the actual arrival time versus the scheduled arrival time. We can use that information to derive new variables, right? Which is really just saying, I'm going to make a new column in my data set from this old data that I have. They've done it here. It's already in the data set, but we don't need the departure delay and the arrival delay, right? Where negative time represents early departures or arrivals, right? And we don't need that. We could have generated that on our own. There's the hour and the minute, the carrier, okay? There's the tail number, there's the flight number, there's the origin, the destination, the air time. I lost my place here. The distance between airports. Fair enough. I don't know why that caught me off guard. Anyways, and then the time hour. Okay. We can use this for more sophisticated things, like considering the weather, which is not here, right? But it might play a role, right? So that might be interesting to consider as well. How would you classify each of these, right? If we just use the descriptions, then there are things like, okay, so the departure time and the arrival time, that seems like, a measurement. Whereas if we think about the carrier, right, the carrier isn't really like a measurement. That's just a fact, and we're going to call that a category, right? And so what we're going to do is we're going to split our variables into two main groups, either numerical or categorical. Um, so let's talk about that here. Uh, Now, let's see here. Oh, might have run out of room here. Let me fix it. Okay, so we've got this subset of just kind of the main variables that I want to talk about. So the departure delay, the arrival time, the scheduled arrival time, the arrival delay, which we could have figured out, right? We could have calculated the carrier and the flight number. So variables included in the subset, those we just talked about, right? And so we said that a variable is either going to be categorical or numerical. And I've got little definitions over here on the side. Categorical can also be called qualitative. So I'm going to stick to categorical and numerical, but just as a side note, before we get too deep into this, depending on what field you go into, and that's going to happen a lot in statistics, right? Depending what field you go into, different fields have different preferences for what they call things. And so that's what makes this course a little bit more difficult, is because we have to introduce all these different terminologies, and then I try to keep it simple by just using one. But it's also important for you to link the two, right? So the categorical variable can also be called qualitative. And really, it's just a quality, or I like categorical because it makes me think of categories. So if a variable can be placed into or split into categories, then it's a categorical variable. Numerical, we can also call quantitative, so some quantity, right? And a numerical measurement, it just sounds better to me. It is a number, so it's numerical, but it's also a quantity, right? A measurement, and so we could call it quantitative. Okay. So categorical is data that can be grouped into categories, right? Sounds kind of obvious, right? But it's going to need a little bit of work to be able to classify variables as either categorical or numerical. Even more confusing is that a categorical variable could further be classified as either nominal or ordinal. Now, a nominal variable has no organic order. So, for example, the carrier here is a categorical variable just because it's not a measurement, and so we can't do any calculations on it. We could count how many are in each group, but that's about it, right? And so that's what we do for categorical variables. So here we've got these distinct groups or categories, so it's a categorical variable, right? And here, is there some organic order to the carrier? Unless you go alphabetical, I don't really think so. Usually, if there is organic order, it's something like, oh, I ask you what year are you in for university or college, and so first year, second year, third year, fourth year, right? And so then we have these natural orderings. Okay. Whereas here for the carrier, you could, so a lot of the time you could kind of argue it either way, and it's not, set in stone. If you went the route of, well, I could do them alphabetically, then maybe. But in general, I would say this has no organic order. The carrier has no organic order, so I would call it nominal. Okay. Notice that here, right, a nominal variable has no organic order, or I guess I shouldn't have extended it so long. Right. Whereas ordinal makes me think of order, so it has some organic order. Less obvious here is the flight number. Now, the flight number is a number, so it is numerical. However, as a variable, it's going to be categorical, right? Because these aren't measurements that someone has, used some measurement tool. These are numbers that have been assigned to this flight, right? And it's really just an ID, right? And so as soon as it's just an ID, then it's a categorical variable. Yeah. In this case, right, it's easier to see that maybe there is some organic order, maybe there isn't, but probably not, because each carrier probably has its specific way of numbering, but I don't know. So you could argue either way. And I know that's not helpful, but that's how these things go, right? So if you tell me that, yes, the flight number is ordinal, you would have to justify it by saying, because it clearly has these numbers that I could list from decreasing to increasing, right? So it has some, so you'd have to argue that it has some organic order, right? Whereas if you tell me it's nominal, then fine, but your argument would have to be, well, because there's no organic ordering to the flight number, right? And so whichever one you pick, as long as you argue using these two kind of definitions, then you're fine. Okay. So let's see here. I want to tack on the numerical variable. It got cut off. Oops. Here, but let's bring it in. Whee, got big. Trying to keep it the same size. It's a little tricky. Okay, so a numerical variable is any measured variable or any measured value. So things like speed, distance, heights, weights, those are all numerical variables, right? So for example, the departure delay, the arrival time, the scheduled arrival time, the arrival delay. So the arrival time and the scheduled arrival. So as soon as we talk about time, it's a little bit of a gray area. It's a little bit tricky. I would argue that in this case it is numerical, but only because we're not actually going to use them explicitly. I'd have to think about a little bit more. Maybe I would put them into groups like before 9 a.m. And create categories. That's something that we can do as well. Okay? And so one trick that I find really useful is if it makes sense to talk about the average of a variable, then it's definitely numerical, right? So it's a little bit vague still because well, how do you know if it makes sense? But you're going to just have to kind of argue your way to it. If it makes sense to talk about the average, then it's definitely numerical. And so for that reason, again, going back here, the flight number, it doesn't really make sense to talk about the average flight number, right? Because it doesn't mean anything. It doesn't tell me anything. It probably doesn't even exist, the average flight number. That's weird, right? Whereas maybe the departure delay, the average departure delay, that sounds like something we'd be interested in, right? The average arrival delay, definitely something that we would be interested in, right? And so those are definitely numerical variables. And then here's our gray area, the time, right? Does it make sense to talk about the average arrival time. Not particularly, right? But luckily, it's not something that we're going to have to analyze, right? We would be analyzing the delay, the departure or the arrival delay. Okay. So that brings us to another classification that we can do. So a variable can be grouped as either a response variable or an explanatory variable. Now, a response variable can also be called the dependent variable, right? And the reason for that is because the response variable or the dependent variable depends on changes in the explanatory variable. So an explanatory variable can also be called the independent variable. Again, it depends on what field you head into later on. But for us, I'm going to stick to, so I'm introducing the connection here between the response and the dependent variable, but from now on, I'm going to use the response variable and the explanatory variable. In a research question, the variable that we're interested in is the response variable, and all other variables are explanatory variables, right? And so explanatory variables are collected or used to help explain changes, right? And so here the explain and the explanatory, that's where it comes from. So they're collected or used, whether they already exist or we're collecting them, to help explain changes in the response variable. Changes in the response variable. So the research question, whatever it is, okay, whatever it is about, right? And so if we want to know something about the average departure delay, right, then that would be our response variable, right? And everything else would be an explanatory variable, right? So there's usually only one variable that we're interested in knowing something more about. So that's the response variable, and then all the other variables are explanatory variables. Got a little example here. So what I want you to do is consider this research question. So now I'm giving you a research question, and the subset, or rather these variables that I've given you down below here. And I want you to classify each of these as either a response variable or an explanatory variable, and also as a categorical or numerical variable. We already sort of did that, but just as some practice, right? Try to classify these on your own. Okay, so I'll let you pause it for a second and just work through that, and then we'll go through it together. Okay, so give it a shot. The research question asked, what is the mean departure delay for flights departing from New York City? And so we want to know about the departure delay, right? Which means that the departure delay is the response variable. And so every other variable here, they're just there to try to explain the departure delay, right? The arrival time, the scheduled arrival time, those are all kind of baked into the arrival delay, but that's okay. Um, and then the carrier and the flight number, these are all there to try to help us explain changes in the departure delay, right? And so that is our response variable, and all these other ones are going to be explanatory. And what I'm going to do is I'm going to cheat and just copy and, oh, easier said than done. Wait. I think you get the idea, but so close. So all the other variables are going to be explanatory variables. Now, so a variable is either a response variable or an explanatory variable. Fine. And then alongside that, we could have it be a numerical variable or a categorical variable. And then if it's a categorical variable, we've included those extra categories in the categorical variable where we could classify it as ordinal or nominal. And there are more categories or subgroups of these variables, but I keep it very high level. And so we're just going to talk, and of course there are more groupings within numerical variables, lots more. But for us, we just need to be able to really kind of drill down on numerical or categorical, and that's basically all that we need. Okay. So the departure delay is definitely a numerical variable. Remember that trick where you kind of ask yourself, well, does it make sense to talk about the average? Yes, it makes sense to talk about the average departure delay. The arrival time, for the sake of just kind of moving through this, let's say it's numerical, the time is numerical. Kind of could argue it either way, but for us, I'll say it's numerical. And so that means the scheduled arrival time is also numerical. The arrival delay is definitely another delay, so that's numerical for sure. I just wanted to add a little note here, right? We could consider these categorical, right? We could. It just depends on how you want to present information. So sometimes we have to kind of massage our data so that we can present it in a way that we like. So I'll leave it as numerical, but you could treat it as a categorical variable. The explanatory, or sorry, the carrier, we already decided was a categorical variable. And I'm going to say it was nominal, right? Because there's no order, there's no natural ordering. Oh yeah, definitely. United Airlines should be before British Airways or whatever, right? There's none of that going on. The flight number is also categorical, right? And so that's a bit of a curveball because it is a number, but it's not a measurement. And so categorical, and I'm going to say it's nominal as well. I guess I didn't write nominal, but that's what I meant. Because there's no natural ordering unless, you kind of listed them in increasing order or something. But good. So let me just bring this whole chunk in here. Some of it we've already discussed. Maybe. We already talked about this. We collect explanatory variables with the hope that they might explain changes in the response variable, right? And so I already mentioned that, but often what happens is we have some information that we want to look at and we want to visualize. And so let me just crop top this here. Okay. This is what we call a scatter plot. Okay. And this is just of the first 100 data points. Okay. And so what's going to happen in general when we're mapping two variables against each other, we're always going to have the response variable on the y-axis. And as a little reminder here, if we're talking about our axes right here, this is our y-axis, and then this is our x-axis. Right. Now, on our y-axis, we're going to have our response variable. And so here, the response variable always goes on the y-axis. And in this case, we already decided that the departure delay was the response variable, and so it makes sense that we put it on the y-axis. In this case, we're using the arrival delay as a potential explanatory variable. Now, notice that we're going to focus on kind of the relationship between only two variables for this course, right? Because otherwise it's hard to map them out. But right, but we could look at a series of scatter plots and look at the relationship between the explanatory variable and the response variable. So this is the explanatory variable. Okay. And I know if it's been a while since you did math, or maybe you don't like math, that's okay. Very few people do, and they take this course. That's okay. And so you might have to develop some tricks to remember kind of which is the x-axis and which is the y-axis. Well, the reason I really like to use explanatory is because it has this built-in kind of connection between, okay, the explanatory variable goes on the x-axis. Great. Okay, and how do you remember which is the x-axis? Well, the cutest way that I've heard someone tell me was, it was a student from a long time ago, and she goes, oh yeah, I have the hardest time and I can't remember. And so what she decided to do is think about some little guy down here. Here's a little guy. And now imagine that this axis was upright and then it's falling down, and then he's like down there going, no, making an X. And so I just thought that was like the cutest, most elaborate way of remembering which is the x-axis and which is the y-axis. But yeah, so let's see if I can make him crosses. He's like, no, that's like pointing down. I'm not a very good drawer. Anyways, how about like this? No, you get the idea. And so anyways, it is what it is. At least you heard the description, otherwise it looks really weird. But yeah, so however you need to remember these, and to help me remember, I just remember that the explanatory variable goes on the x-axis. Okay. So the response variable will always be plotted on the y-axis, and the explanatory variable is plotted on the x-axis. what we'll find is that all our analyses, so everything that we do in this course, depend on whether we have a numerical variable or a categorical variable. So being able to identify them will be imperative. You don't want to use harsh language like that, but it's true. So depending on if we have a numerical variable, that's going to send us down a path of analyses and kind of appropriate things to do with this variable. Whereas, like we talked about earlier, if you try to take the average of a categorical variable, that doesn't make sense, right? And so if you have a categorical variable, it's going to send you down another path of appropriate ways to summarize this thing and to analyze it. Okay, I'm going to pause it briefly here. Okay, so next thing I want to talk about is just data collection. So we've established, okay, we have a data set and it, it looks like a spreadsheet and all the columns, they're variables, and we could, with some practice, we can classify those variables. And in each row is an observation, right? Or some subject that we've collected information on. Or in the case of this data here, right, it would be each flight that left New York. I think it was left New York. Yeah. In this case. Anyways. So just briefly to talk about data collection, and also with kind of a warning, is that, well, data collection, it's really important, but it can also be really kind of difficult. And so a lot of the time, the information has already been collected in some way. So you can find tons and tons of information and data that's been collected online. And if you have to collect your own data, you need to make sure you're... It's like, this is very important. Okay, I can't believe I haven't told you this before. This is so important. Anyways. And I realized I should probably stop announcing when I pause it, because it's just me here entertaining myself. But that's okay. I'm used to having a class, so I'm used to kind of giving a play-by-play of everything that I'm doing. So you need to make sure your sample is randomly selected. That's what was so important. Maybe that's too dark. What if I do it lighter? No, same color. Okay, fine. Back to yellow. Boring. So if you have to collect your own data, you need to make sure that your sample is randomly selected. And so I want to give the definition of being randomly selected, right? So randomly selected means that each individual in the population, so all the people that you're trying to get information from, has the same probability of being selected in the sample. Now, that's okay. So everyone in the population that you're interested in has to have the same probability of being selected in the sample. So of course, there are always going to be kind of obstacles with that, but your goal is to make sure that your sample is as randomly selected as it can possibly be. Okay. And the reason for that is because in order for our sample to be representative of the population, our sample must be randomly selected, right? And so my supervisor for my master's, he would always do this kind of circle. So he would do something like, okay, so you've got this, here's your population. let's say you want to learn something about a specific type of ant, right? So maybe some ant, right? And so we understand that we cannot collect information on every single ant of that, even if it's of a specific species. Um, are there even ant species? I don't know. I'm just making this stuff up. And so, so you're interested in this very specific ant, but we understand that even if we wanted to, we probably couldn't collect every single ant and measure, the length of their legs or something like that, something weird. So what we do is, of course, we take just a subset here, which we call the sample. Okay. And so this sample has to be representative of the population, because remember, the goal of statistics is to be able to take sample information, right? So take the average length of the ant leg or something, I don't know, to learn about kind of what would be reasonable for the population, right? What would we expect to see in the population? Ultimately, we want to learn something about the population from the sample. And so it took me a long time, and now I find myself using this silly circle with a circle inside. And I remember thinking, it was probably on the first day of classes, and I'm like, that is such a stupid, why did he put that on the board? That is so obvious. Um, but now I think it's a really important thing to highlight. But I understand that it feels obvious, and it is obvious, but it's something that we need to keep in mind, right? And so in order for this sample to be representative, it has to be randomly selected, right? And so here, a lot of the time, it might be tempting, if you're collecting your own data, then it might be tempting to say, oh yeah, I need to have a 50-50 split of males and females, for example. Or maybe I need to have 100 people from first year. What pen? Right, you need to have 100 people from first year, 100 people from second year, 100 people from third year, etc. But we can do that, but ideally, if you're popular, or if your sample is randomly selected, those those trends or those characteristics will shine through in your sample, right? So just randomly selecting it will likely highlight all those characteristics that the population has. Okay, so that's why we want a randomly selected sample. So let's talk about sampling. Sampling can be a little bit tricky, okay? And there's lots of different ways that we could collect a sample because, well, not because, but what we'll realize, right, is so statistics wouldn't exist if we weren't able to collect information, right? And so there's a lot of work that goes into the actual sampling, right? And the whole goal is to make sure that your sample is representative of the population. So most often sampling is done through surveys, right? There are other ways, but if you are kind of conducting sampling, then you're probably doing a survey. There are situations where you don't, but in general. When you have survey results, it's really important that you include the response rate. So of course, the procedure would be, okay, you set out, how am I going to collect the sample? That's the establishing the sampling. And then you go out and you collect it, you analyze it, and then you write a report. Now it's going to be really important that you include your response rate. The reason for that is, so the response rate, let's just talk about it, is the number of responses over the number in the original mail out, or however many people you tried to contact. Or number of peoply. I combine people and you. Well, that's a new one. People you tried to contact. Oh. All right, so however many people you tried to get information from is the denominator, right? So in the bottom here, and then the number of responses that you actually got. So I've got a little example here. Why it's so important is because if you say, okay, my response rate was 200 out of 250, that's a great response rate, right? And the idea is, okay, well, I was trying to reach 250 people and I only got information from 200. But what this means is that this sample is fairly reliable, right? This sample information is going to be fairly reliable. Whereas a response rate of 200, so again, the number of responses that you got was 200, but let's say you tried to reach 10,000 people, well, that's a terrible response rate, right? And so a low response rate indicates that we have less reliable results than with a high response rate. And so we need a reasonably high response rate to draw reliable conclusions about the population using our data. Because if you tried to reach 10,000 people and only got information from 200 of those, it's very likely that that sample is not representative of the population, and that's the problem, right? Whereas if you tried to contact 250 and you heard back from 200 people, well, then if 250 was going to be representative of the population, then 200 is probably also representative of the population, right? Whereas if 10,000 would make sure that you were representative of the population and you only heard from 200, that is not going to be very reliable information, right? You can still use it. Ideally, you won't have to do that, but you could still use it, but you'd have to highlight your low response rate, and you would have to say, okay, well, because of this low response rate, we can't really conclude anything, right? We can't draw any conclusions, but here's what we found, right? That's fine. You'll even see that on StatsCan. They'll have a little asterisk saying, oh yeah, the sample size was too small, and so it kind of read at your own risk type of deal. Right? So how do we collect a good sample versus a bad sample, right? So we always, top of mind should be, okay, if I have a randomly selected sample, then that's well on my way to a good sample, because then I can use that information to talk about the population pretty reliably. Let's talk about bad sampling first. So bad sampling is any sampling that's biased. And there are many forms of bias, and you've probably used the term bias just in your regular life, right? We understand, we have this idea of what bias is, but technically, the definition of bias is systematically favoring one outcome or a group of outcomes potentially, but usually we just say one outcome. So things like voluntary samples, right, where you just approach people, and or whoever approaches you may be even worse. Those are voluntary samples. If you're on Facebook and a little like, hey, will you do our survey? That's a voluntary sample. And that introduces some bias, right? There are only kind of two types of people, either those strongly opposed or strongly in favor of something are going to answer those typically. Me, I try to answer as often as I can, even if I don't really care about it. But that's just me. It's very time consuming, so I can't even recommend it. But anyways, so you've got voluntary samples. There are also convenience samples, right? If we think about those ants, right? If we want to talk about a specific species of ants, maybe I only collect them in my neighborhood when I should be going all across the city, maybe, and trying to find these ants. Maybe I know where they are, and then I just go there and collect a sample and be done with it. But that would be a convenience sample, right? Um, Also, just kind of if you went and stood outside the door and waited for a class to end, and then you just asked everyone in that class, then that would be a convenience sample. So some other things to avoid or potentially be aware of with surveys. Now, surveys are hard because it's hard to get people to answer your surveys. Um, and so often we just kind of have to highlight the deficiencies of our survey, right? So here's the information that we found, and here are some problems which could affect the results of this data. For example, well, maybe my response rate was low. You'd have to highlight that. If there was undercoverage, right? Maybe there's some group that's underrepresented or not represented at all. Non-response is slightly different, where you tried to contact them and they just you didn't hear back. A lot of that is captured in the response rate, but it's a problem, and it's something that you'd have to highlight in your report. The response bias. So even the wording of questions, and I've got kind of an interesting example. Things like the question order, right? You read the question, and then maybe it gives you, as someone who's completing the survey, maybe, from the order of the questions, you start to get a feeling of, well, this is how I should be answering this question. Whereas if it was kind of in a better order, maybe you would just answer just how you feel. But so these are some problems that can come up, and often there's nothing we can really do about it, truly, but often you would just have to highlight it in your report and be forthcoming about these deficiencies, and then but try to address things like the wording of the questions or maybe the question order. So let's see here. I've got two kind of interesting examples here, and maybe I'll include the last little bit on this page here. But I like to bring these in because it's shocking. I find it shocking. And so so an example of how important the wording of a survey is: how do Americans feel about illegal immigrants? So should illegal immigrants be prosecuted and deported for being in the US illegally, or shouldn't they? Okay, that's a weird question. So ask this question in an opinion poll. 69% favored deportation. Okay, yikes. But when the very same sample, yikes. So the exact same people, they were also asked whether illegal immigrants who have worked in the United States for 2 years should be given a chance to keep their jobs and eventually apply for legal status. 62% said that they should. Now, math is hard, but there's some overlap there, right? 69% said, oh yeah, yep, I'm in favor of deportation. Okay, great. And then 62% said, oh no, let them stay. Yep, that's fine. And so it's just so important how you word these questions, and you want to keep it as neutral as possible. Another example, of course, these are all touchy subjects, right? They're always, in statistics, we always kind of deal with touchy subjects, and um, but that's just how it is. Those are the things that we want to study, right? So, so what about government help for the poor? So only 13% think that we're spending too much on assistance to the poor, but 44% think that we're spending too much on welfare. So notice just the choice of words there has a huge effect on the results. Okay, so let's talk about good sampling. Good sampling is a randomly selected sample, and there are more things that we could consider, but just in general, a good sample is just a randomly selected sample. Just bring this in here. Okay. So good sampling, there are a couple of different techniques, or there are many different techniques. And of course, it's kind of a big field of study, but a simple random sample is the most basic random sample, and it, as the name suggests, right? So an SRS is just a simple random sample where you have your population and you just select people randomly. How do you do that? What are some options? You could use a random number generator, right? So thinking about, maybe a university, right? So a university has a list of all the students, right? They have these student IDs, and they know their whole population, and they want to send out a survey. And so they're going to take a simple random sample. You don't want to use things like the student number to randomly select student numbers, because I don't know if there's some underlying information in your student number or not, but there could be something like that. So then what I would probably do is I would just assign everyone a number, right, that has nothing to do with anything, right? And just assign everyone a number, kind of go down the list, and make sure you're not, sorted by alphabetically or anything like that, although it would be okay. But so you assign everyone a number, or maybe you want to assign them a random number. There are a couple of ways you could do it. Let's say you assign them a random number. So there are random number generators. Random.org is one that I've used quite a bit, and it'll just generate random numbers. If you're using something like in Excel, there is a random number generator, but it's actually not that random. It's kind of predictable. So so you want to try to make it as random as you can. So maybe go to random.org, and it'll just generate a list of however many random numbers that you need. Then the next thing you could do is you could assign them to everyone in your list, and then sort them, right? Take the top 5, the top 10, the top 100, whatever, maybe the lowest 100, every fifth one, something like that, right? You could have some sort of scheme where you sample using that random number. Okay, so that would be a simple random sample. Okay. There are more sophisticated techniques, things like a stratified random sample. Okay, well, I'm almost done here. Stratified random sample. The population is divided into groups called strata. Okay, and I've got a little subnote here. So the strata are chosen so that similar cases are grouped together. Okay, and then you randomly sample a set sample size from each strata, right? So let's say you have 4 strata, and then you collect a random sample of 10 from each strata, right? That would be a stratified random sample. A little bit tricky to keep track of, but the cluster sample is slightly different because the population is divided into many groups called clusters. Notice that the clusters don't necessarily have to have similar cases grouped together. So neighborhoods might be kind of naturally occurring clusters in a city, right? And then, so what we could do is we could randomly sample a fixed number of clusters as opposed to people within the strata, right? And then you include all the observations from each of those clusters. Okay. So a little bit hard to kind of wrap your head around, but I'm just introducing some of these ideas, right? The last one I want to talk about is multi-stage sampling, which is like a mashup of cluster and stratified random sampling. So it's a cluster sample, meaning you have divided your population into these groups, right, clusters. But instead of keeping all the observations in each cluster, right, so then you randomly select your clusters, cluster 1, cluster 3, cluster 6, whatever. They're in my sample. That would be cluster sampling. But then if I went in and I collected a random sample within each selected cluster, right, so then I take a random sample of 50 from each of the random clusters that I've selected, that would be multi-stage sampling. You can see how there's 2 layers, multi-stage sampling. Good. In general, there are 2 ways that we could collect data. Okay. And so we could do observational studies or experimental studies. Now, when we think about data collection, often our minds go to experiments, right? Oh yeah, I increased the temperature and then recorded how many bubbles there were or something weird. Anyways, so observational studies, you're just monitoring or you're observing, right? You're looking at what's going on and you're recording it, right? Or you're asking people their opinions and then you're recording it, right? So surveys and user data are some common ways of collecting observational data. So observational studies, again, so we got these like branches of things, but observational studies can be divided into 2 forms: prospective studies, and a lot of it has to do with etymology, right? So prospective is in the future, and so here for a prospective study, you identify individuals and then you collect information as events unfold, right? You probably well, we're all getting vaccinated at this point, and so right, you've probably been contacted, oh, will you complete this survey? And so that would be a prospective study, right, where you contact people, hey, will you participate in this study? Great. And then they collect your information as you go. A retrospective study, right, retrospective is in the past. So then maybe you're just looking at census data, for example, in Canada from the years 2005 to 2015 or something like that, right? So in the past. So this is all data that has already happened. Notice in observational studies, so these are all observational studies, we are not manipulating the results at all, right? We are just observing, collecting. We're not actually doing anything to produce the response. Even that departure delay data set that we used, right, that's just observational, right? We've recorded information as it happened, and I would probably call it a retrospective study if I had to, because those flights probably already happened. Whereas an experiment is where we can control all the factors or many of the factors that might affect the response variable. Okay, and this is really important. Experiments are the only way to establish a causal relationship between 2 variables, right? Assuming you can control everything in the environment. So in order to be able to say that this causes a change in this, the only way that we can do that is with an experiment, and a really, really controlled experiment. So when conducting experiments, it's important that we have a blind study, especially if we have human subjects involved, right? And so a blind study is when the subject does not know whether they're receiving the treatment or a placebo. I think we've all watched enough like Grey's Anatomy, House, whatever, to understand that, okay, what a blind study is. Sometimes they get the treatment, sometimes they don't. But also, we know what a placebo is. A placebo is a fake version of the treatment, like a sugar pill. So, because you don't want to have a group that's not, you're not doing anything to them, it makes them kind of suspicious that maybe they were in the control group, right? Ultimately, what you would really want to have is a double blind study. Sometimes it's not possible, but a double blind study, right? It's blind to both participants. So it's a blind study where the person administering the treatment also doesn't know what treatment the subject is receiving. Okay. So, so that's really what you want. Okay. Let me see here. I think that's where I wanted to. Good. Okay. There. You did it. Part one. Done. Um, Great.